PCBWay kindly provided me with all the custom parts for this project. If you saw my first video, you know that it's my ultimate mission to make the perfect flying graduation cap. And yes, this one is going to be even better. Anyway, let's first open that package. We have these beautiful 3D printed nylon propellers and a bunch of carbon fiber laser cutted parts. But why even make a new version in the first place? The previous design worked pretty well and had a lot of cool features. But there are definitely some key things missing that my perfectionist brain cannot live without.
For one, reliability. It was very hard to successfully open the mechanism because of the many friction points.
Also, like some of you pointed out, putting the motors further out is better for stability and allows for bigger, more efficient propellers. Now, I could have tried modifying the existing frame, but since PCBWay reached out to me, I figured I might as well make full use of their carbon fiber laser cutting service and start from scratch. Also, laser cutted parts like this give me way more design freedom, which is also part of the reason it took me so goddamn long to finish this thing. To explain how it all works, I think it's best I split up the design into 4 main parts.
So why not begin with the main carbon fiber frame? Obviously the most essential part. Now, one sheet of carbon fiber definitely wouldn't be stiff enough for a drone this size. But by stacking multiple sheets on top of each other, I can increase the moment of inertia and therefore increase the stiffness of the frame. With a basic design done, I did some tests with laser cutted plywood, mainly to check dimensions and the overall feel of the design, which was very helpful.
But it's just really hard to compare with carbon fiber. Because I want to sandwich the motors between 2 carbon fiber plates, I also need to design some custom propellers. And after some more testing, I got the design mostly figured out in CAD.
It's nice to have a CAD model, but somehow we've got to turn this into an actual drone. And without PCBWay, I would have never been able to do that. I was genuinely surprised how easy it is to get free quotes on parts like this. PCBWay offers many more services like, well, PCB manufacturing, injection molding, and much more. Seriously, thank you for sponsoring this video.
So after uploading my files and about a week of impatiently waiting, I finally got to see all those beautiful parts. To do a first test, I need some spacers that I cut out of some cheap aluminum tubes. I'm gonna say aluminum because that's easier.
Turns out precisely cutting 4mm aluminum spacers is pretty hard. I even spent the day making a custom jig for my Dremel because I originally intended on using way more of these spacers. But the aluminum was just way too soft for the grinding discs.
In the end, painstakingly cutting them with a little hacksaw was the best solution I could think of.
Luckily, the rest of the parts I needed could just be 3D printed.
Easy, right? Eventually I managed to print 4 motor mounts out of carbon fiber PETG for better temperature resistance and 4 truss tubes out of lightweight PLA. After seeing everything together, I decided to completely scrap the custom propeller thing as it just felt way too fragile and overcomplicated. Replacing those propellers with regular 3-inch propellers meant deleting part of the subframe for clearance. In the end, I decided to remove the whole bottom plate altogether because the 2 top plates seemed more than strong enough on their own. The 2 plates are held together with 4 M3 countersunk screws and the aluminum spacers I made earlier. So now we can already start installing the electronics. Basically, I just stole the electronics from the previous cap, except for the camera, but more on that later. The 4 motors are connected to a 4-in-1 speed controller which goes right in the middle of the frame at an equal distance from all 4 motors. Now we can install the motor mounts and the motors, which mostly involves tightening nuts and bolts.
I tried to include more of the building process this time, but it's pretty hard for me to make a coherent video out of all the garbage I've recorded over the last year.
I'm using the same 11-volt LiPo batteries wired in series for a total of 22 volts, connected to the speed controller,
which is rated for 35 amps max.
The battery once again sits right on top of your head, hidden by the gap. This really is the ideal place for comfort and weight distribution.
Apart from dumping PFAS in the environment, 3M also has business in making some killer electrical tape. Absolutely perfect for securing batteries to a graduation cap, I must say. So after doing that 3 times, one for each battery and once because you f***ed the first one up, the batteries are secured. Okay, so next we can connect a flight controller with this little extension that I made. And then the video transmitter and of course the antenna.
The only thing missing now is of course the camera. Because of the new propeller layout, there is no way I was going to fit the old camera in there. This new camera is just small enough to fit behind the front propeller. Some of you suggested that the camera should be able to tilt down so it's easier to land on someone's head. I really wanted to test that out, so that's one of the reasons I made a tilt mechanism using a cheap servo.
So that's all the essential electronics done, but I want to add one more thing.
To save battery, it's best to only power on the drone right before flying. However, plugging in these shitty XT30 connectors from Amazon isn't exactly stealthy. So I had to find another way to quickly power on the drone. After some literal digging in my magic box, I found all the necessary parts. A fiberglass washer insulates the negative terminal from the carbon fiber base.
The positive terminal is pressed down by a spring and the 2 terminals are separated by a little shim. So when you pull out this shim, the 2 terminals are connected and the circuit gets closed. So with all the electronics installed and the firmware updated, I took the drone with me on vacation to do some proper testing.
You've almost certainly just overlooked it. And the reason you're annoyed is because you're sure that you didn't do that. It's one of those 4 things.
Auw. Kloten. Nice. But it flies. It does fly very well actually. It's way more agile than the previous design and it has a lot more thrust. So now that we know it flies, again we have to make it look more like an actual graduation cap.
My previous cap had a rotating cover for the camera and motors. This is no longer possible because the motors are located in the corners. A great excuse for me to experiment with this iris-like mechanism. It's actually a very simple design. Around every propeller sits a little ring which is held in place by 4 of these little hooks. We also have 4 of these very lightweight blades that weigh less than a gram each. These are placed around the little hooks and pivot on the ring. If I now turn the ring, the blades are forced outwards thanks to the little grooves in the blades. This took a long time to get right, but it works absolutely flawlessly now. Now we need to find a way to open all 4 at once. This is done by a central ring that rotates on the aluminum spacers. To make it easier to install, I designed it so you can twist it in and then secure it when it's in place. Originally, I wanted to use a pull mechanism to open the covers like in the previous cab, but there's just no way I could have made that reliable enough. Luckily, there's a better solution. By drilling a hole in one of the rings and modifying the servo horn for my camera mechanism, I could effectively make a release mechanism without adding any extra weight. So when the user pulls the tabs out, the drone powers on and the camera pops out, pulling this little release pin down and opening the covers. They open automatically because I added these little elastic bands to the center hub. With the help of some Velcro, I could secure the base to the cab, just like I did with the previous one, and well, that's basically it. I really thought this was going to be a quick project, but here we are, almost a year later. I made a lot of mistakes, but I was mostly able to correct them. Anyway, let's get this thing in the air.
Welcome to HTX. Acro mode. Armed.
Now, I did try to fly with the camera pointed down, but that will definitely require some more practice. One day I'll learn to fly this thing properly, but I'm very satisfied with the result for now. I guess now I can happily retire from this stupid idea. I'm already working on some new fresh projects, so maybe you'll hear of me. Next semester I'll be studying in Prague, so if you guys have any connections there, please feel free to let me know. Bye.